guys, welcome back to my YouTube channel. We are here now to discuss summary chapter 8. Okay, let's start. Chapter 8 is entitled Subnetting IP Networks. Designing, implementing, and managing an effective IP addressing plan ensure that network can operate effectively and efficiently. This is especially true as the number of hosts connecting to the network increases. So, introduction. Subnet ID or IP network addresses can be structured to represent smaller group of a number. Broadcast domain. Other device uses address resolution protocols or ARP, which send layer 2 broadcasts to known IPv4 address on the local network to discover the associated MAC address. Services. A host typically acquires its IPv4 address configuration using the dynamic host configuration protocols or DHCP, which send broadcasts on the local network location, a DHCP server. Then problem with large broadcast domain. A large broadcast domain is a network that connects many hosts. A problem with a large broadcast domain is that this host can generate excessive broadcasts and negatively affect the network. Slow internet. Slow network operation due to significant amount of traffic can cause slow device operation because a device must accept and process each broadcast packet. Reasons for Subnetting reduces overall network traffic and improve network performance. It is also enabled an administrator to implement security policies such as which subnets are allowed or not allowed to communicate together. Subnetting location. Octet boundaries. Every interface on a router is connected to a network. The IPv4 address and subnet mask configured on the router interface are used to identify the specific broadcast domain. So, subnetting network on the octet boundary. The prefix length 8, so 8 1, then the other is 0. So 255.000, then 16 and 24. Subnetting on the octet boundary. Network address planning. Planning IP address assignment. Planning requires decision on each subnet in terms of size, the number of hosts per subnet, and how host addresses will assign. Planning network subnets requires examination of both the needs of the organization's network usage and how the subnet will be structured. So, performing of a network requirement studies the starting point. This means looking at the entire network and determine the main section of the network and how they will be segmented. Planning to address the network. Primary consideration when planning address allocation. So, IP address ranges. End user client must network allocate addresses dynamically using dynamic host configuration protocols or DHCP. Then servers and peripherals, this should have a predictable static IP address. Servers that are accessible from the internet. Servers must be made available to the remote users and intermediary devices. The devices are assigned addresses for network management, monitoring, and security, and gateway routers and firewall devices have an IP addresses assigned to each interface, which server as the gateway for hosts in that network. So IPv6 global unicast address structured. So have here global routing prefix. This is the prefix or network portion of the address that is assigned by the provider. Then subnet ID used by organization to identify subnets within its site. Then interface ID is the equivalent to the host portion of an IPv6 address. The term interface ID is used because a single host may have multiple interfaces, each having one or more IPv6 addresses. IPv6 subnetting requires a different approach that IPv4 subnetting. The same reason for subnetting IPv4 address space in order to manage network traffic also apply to IPv6. Then subnetting using the subnet ID. Increment subnet ID to create 65,536 subnets. Example of topology. So IPv6 subnet allocation with over 65,000 subnets to choose from. The tasks of the network administration become one of designing a logical sim to address the network. Figure 1. So process of segment network by dividing it into multiple smaller network spaces is called subnetting. Every network addresses has a valid range of host addresses. All devices attached to the same network will have an IPv4 host address for that network and a common subnet mask or network prefix. Traffic can be forwarded between hosts directly if they are on the same subnet. Traffic cannot be forwarded between subnets without the use of router. To determine if traffic is local or remote, the router uses the subnet mask. The prefix and the subnet mask are different ways of representing the same thing, the network portion of addresses. So in IPv6, subnetting requirements a different approach than IPv4 subnetting. An IPv6 address space is not subnetted to conserve addresses. Rather it is subnetted to support a hierarchical logical design and of the network. So while IPv4 subnetting is about managing address scarcity, IPv6 subnetting is about building an addressing, right, but based on the number of routers and networks they support. So I think so this the summary for chapter 8. So thank you for watching.